Hello everyone, welcome to week 4, Fractional Exponents. Again, make sure you read the sections in the book concerning fractional exponents and look at the videos that I've recommended to help you gain a better understanding, and we're going to look at a couple of example problems here concerning those fractional exponents. Now when you're dealing with fractional exponents, I think you will find it helpful for you to convert your numbers into either whatever they are, perfect squares or perfect cubes. For example, 27 is equal to 3 times 3 times 3, or 3 to the third power, and 64 is equal to 4 times 4 times 4, or the same thing as 4 to the third power. So when we write these out, I think you'll find it helpful if you do the numbers, change the numbers into the perfect cubes or whatever they are, perfect squares. And remember, you have to distribute this outside exponent to each base on the inside. So 27, or 3 to the third power raised to the 1/3 power, x to the 6th power raised to the 1/3 power, all over 64, which is 4 to the third power raised to the 1/3 power, and y to the 9th power raised to the 1/3 power. So again, we've gone over this, and when you have a power to a power, you just multiply those exponents. So that's 3 to the 3/3 power, x to 6 over 3 power, 4 to the 3 over 3 power, or the 3/3 power, and then y to the 9 over 3, or 9/3 power. Then you just simplify those exponents. So we have 3 over 3 here, which is 3, that'll be to the 1st power, so 3 to the 1st power, or just 3. X 6 over 3 will make x square. That'll make 4 to the 1st power. Y to the 9/3, you can simplify that to make y to the 3rd power. I cannot reduce that fraction 3/4. I only have x appearing once and y appearing once. They're both positive exponents, so that is fully simplified. Okay, so again, I changed my numbers to their perfect cubes in this case, because 3 times 3 times 3 was 27, or 3 to the 3rd. Then 4 to the 3rd was 64. Then I distributed that 1/3 power to each one of these. And remember, an exponent on the inside of the parentheses with an exponent directly on the outside of the parentheses, you multiply those exponents. Okay, let's look at another one of these problems. Alright, so we have 4x to the 3rd raised to the 2/3. Then we have 8x squared y squared raised to the 1/3. So again, I'm going to change 4 to 2 squared, because that's the same thing as 2 times 2. And I'm going to change 8. That's the same thing as 2 times 2 times 2, so that'll be 2 to the 3rd power. So we'll have 2 squared to represent 4 raised to the 2/3 power, and then x to the 3rd raised to the 2/3 power. 8 is the same thing as 2/3, or 2 to the 3rd power, sorry, raised to the 2/3. Let's try this again. Alright, so we have 8, which is 2 to the 3rd power, raised to the 1/3 power, and then you have x squared raised to the 1/3 power, and then you have the y squared raised to the 1/3 power. Alright, so let's simplify these. That makes 2 to the 4/3. That makes x to the 6/3. That makes 2 to the 3/3 x to the 2/3 and y to the 2/3. Now before I simplify these fractions, I see I have some like bases here with my 2's and my x's. So before I simplify these fractions, I want to go ahead and combine my like bases. Remember we said that we could either just subtract those exponents, or you could move this one up, which would change that to negative 3/3. So if I subtract those exponents, 4/3 minus 3/3, it's going to give me 1/3, 2 to the 1/3 power. So this would simplify to 2 to the 1/3 power. This right here, my x's, x to the 6/3 over x to the 2/3. I can just subtract those exponents, and they already have common denominators. So we can just subtract the fractions like they are. 6/3 minus 2/3 is 4/3. Now there's nothing I can do with that y, so I'm going to have to leave it in my denominator like that. I don't have any negative exponents. I've combined my like bases. So that's as simplified as I can make this one. Okay. Hope that helped you out. That's it for the fractional exponents. Be sure to go through all of your lecture materials and those extra videos that I suggested. And good luck.